what I was doing is like, let's say I had some active synthesis issue. I was like, instead of starting with doing stuff which is like really, so just go through that.
Okay, ladies and gentlemen, it's good to see you. Thank you for joining us. A very big crowd for what is going to be a relatively short lecture. I'm a bit suspicious. This homework 4, maybe everyone's here for homework 4 tips, I'm thinking. Well, I'm going to have some for you. Reviewing this for this lecture, it struck me just how difficult C++ and in particular performance optimization is if you don't do it consistently. I haven't really programmed in C++ since about a year ago when I taught this course previously. It's mainly been C# for the new courses, for the new course designs, and for my existing courses. But getting back into it, one of those magical things about C++ is that it does ask you a lot of very interesting questions about how your data is stored, where it is stored, and how you move that data around your program. For instance, one big thing on homework 4 is, can you avoid making copies? Can you avoid making copies of, temporary objects? Can you stay efficient with that? And so let's go ahead and get into it. If you look right here where we are midway through homework 4, okay? I would not panic if you haven't started the homework yet, but you're going to want to get to that as soon as you can. Homework 4 is not homework 3. It is no longer warm-up time. Homework 4 does have some very difficult performance test cases that you're going to want to have some time to profile, to experiment with, okay? To kind of work your way downward until you can get within that 30% range of the staff solution. You do that, you get full points. So we are midway through, and another quick thing, be sure to at least take a glance at some of these readings that have been posted in the first 2 columns of the schedule. They aren't mostly they are not essential. But on occasion, you will find stuff that is a bit relevant to your homework. Discussion of different containers, for instance. If you are a little bit rough on that, then it might be a good thing to check out. Okay, I think I was up like. You want to see why I was up at like 3 a.m. last night? It was This is going to shock you. I don't want to dwell on it too long, but I was working on the new course. And in particular, the course test bed, we got some features, in particular, moving platforms working, okay? So when you land on a moving platform, one big common issue in games is that it'll slip out from underneath you. How do you prevent that? How do you make sure that the transforms that the platform is undergoing also apply to your player character? One technique is to just parent the game object, to the ground that you're underneath. But this comes with some issues. For instance, if you have an object that scales, your character will grow or shrink, okay? So you have to do a lot of funky business to try and prevent this and get it just right. And sometimes it's very, very hard to. One interesting thing here, and you might not be able to see it, but this is kind of a multiplayer game. How do we synchronize these platforms, mostly across players on different machines? How do we do it? In a typical game, what you would do is you'd have a platform that would be network synchronized, and you would have the platform send its position updates every frame across the network, and then everyone would know where these objects are, and you can just replicate it. If you don't want to deal with that complexity and that bandwidth of sending that information every frame, what you can do instead is find some way to synchronize all of your players. So I found a really coarse one. Basically, all of these platforms are using the UTC time to decide where in its cycle it should be. Now, if your computer is properly kind of synced up to UTC time, then within a second or so, as you can see, it's about a second delayed, things should be synchronized. There's a better, more precise way to do this. What do? Well, when you first connect to the multiplayer server will send you a time, and from that you can extrapolate. That way, pretty much everyone is in sync, and it's all good. You only have to send one little tiny piece of information back and forth on the server, and you are rocking, okay? So anyway, all of this business kept me up till about 3 last night, and so if I don't speak very smoothly, that's usually, my vocabulary is usually the first thing to go as I get more and more tired, okay? So what I want to do is I want to talk briefly about a very kind of interesting engine. Yes, question? The live stream? Yep, I think so. Yep, it should be going. Is the Twitch stream kind of delayed?
Keisha's not able to see it.
Twitch.tv Yarger. Let's click. And there we are. Hey, let's go. Cool. Looks like it's working. 7 people watching. That's very cool. Okay, so hopefully that comes in. If it doesn't, remember this is all recorded on Twitch, but then also it's archived on YouTube forever, okay? All right, so we got a really cool engine today, I'd say kind of a dangerous, a deadly engine. This is an engine that kind of sort of killed a few of its own products. How did it manage that? Well, this is an engine that was made for Final Fantasy XIII. It was going to be a trilogy of Final Fantasy XIII games. It was called Crystal Tools, and it released on the Xbox 360 and PlayStation 3 kind of generation. And this really was a fantastic looking game. Okay, a fantastic looking engine. It was very, very good at special effects, artistic effects. It was very, very good at representing kind of an anime style. And the games made for the engine looked just exceptional for their time, okay? Interestingly, the Final Fantasy series, how many of you have played it? Final Fantasy, as a series, for a long time, had a mandate internally to remain about one generation ahead of its peers in terms of its aesthetic and graphical quality. And for a while, they really managed this fairly well. This is an old-looking game, but it is Final Fantasy VIII. It is for the original PlayStation. And if you compare what you're seeing here to many of the games that you find on the original PlayStation, this actually looks fairly detailed. Okay, despite the low resolution, the characters do look pretty good. The monsters look great. The backgrounds look pretty solid. This is a PlayStation 2 game, okay, Final Fantasy X, Final Fantasy X, and for its time, right, the PS2 was a bit underpowered compared to the Xbox, the GameCube. It also had just tremendous effects, fantastic character models. You can barely see Titus here, but during cutscenes, during battles, any close-up of the characters, they really come through. Their personality, their style, their background, all of that. And so they managed this for a long time. With Final Fantasy XIII, they kind of managed it here, but they ran into a massive problem. This engine, despite looking fantastic, was not able to handle a lot of the features you would typically find in an RPG. It was not really good at handling large worlds. It was not good at handling scenes that had a lot of characters, a lot of geometry. And the engine was just slow in its development. The results were great, but it was coming along very slowly. So this game, Final Fantasy XIII, which the engine was trying to support, was very troubled. The problem was that the artists and designers, the people producing content for the games, had to sit around and wait for the engine to catch up. The engine itself was coming along too slowly. The timelines got messed up. And so the team, running out of time, had to start resorting to very, very simplistic level designs and very, very simplistic gameplay structure. So this is probably not what you think of when you think of a large AAA RPG, especially these days. This is a game that is usually regarded as a beautiful hallway walking simulator. Gorgeous environments, enemies, characters, all that. Very fancy, very luxurious. But this is the gameplay. You walk down a hallway and you get into a battle. You then keep walking, you get into a battle, you get into another battle, another battle. If you want to do some exploration, there's a little bit of that. You see this right here? Look really, squint your eyes, okay? You see this? Sometimes there will be a branch in the path, and you'll walk down it for about 5 seconds to find a hidden, air quotes, hidden treasure chest, at which point you unlock it, get back on the main path, and then continue on. So a very, very linear experience. And a lot of players, that didn't really resonate with a lot of players. And you can see it's many chapters in the game that look this way, okay? Here's a good meme that kind of works. Yeah, you're basically just walking and watching cutscenes and the occasional fight, and then you walk some more. There's one map that tries to buck this trend. My impression is that it kind of came in very late in development, once the engine could finally support it. But yeah, it had a big problem, okay? So the game itself is very, very divisive. One of the, I think, lowest rated games in the Final Fantasy franchise, but it still has a lot of very interesting things going for it, and I recommend you look into it. It's a troubled game, but it's troubled in very interesting ways. The takeaway here for us is that when you have a proprietary game engine, you have to be really careful because it can come back to bite you. It can provide you state-of-the-art aesthetics that none of your rivals can compare to, but it can also hold you back, okay? If development of the engine struggles, any game that depends on the engine is going to struggle as well, okay? One of the risks of having a proprietary in-house engine, all right? Hopefully it's worth it. All right, so a quick reminder, I said this on Monday, but it's still true on Wednesday. On Thursday, we'll be doing The Secret Life of Games, an intro to hacking and modding. If you have ever wondered how to create your own cheat code, how to create your own mod, we're going to be doing that for 2 games live tomorrow, okay, at IGDA Ann Arbor, downtown Ann Arbor, okay? I saw this post, which is kind of neat. Has anyone ever heard of a game series called Age of Empires? This is a very well-known kind of RTS series. It has kind of a historical flavor to it. You fight wars, you try and build up an army and an economy to support it, and all that good stuff. It was one of the early RTS games in the genre, and one of the original developers. You know what's amazing? It's amazing how young this industry is. You think about these old games, these legendary games, right? And the people who made them are still around. Some of them are still working. They might see your Reddit post, okay? And they might just pipe in to tell you exactly what happened. So we are very fortunate to be in early on such an impactful medium. But one of the developers of the original Age of Empires hopped in and commented on this topic that was saying, Age of Empires is written in assembly. Is this actually true? And the answer is yes, partly. So in this era, okay, the 80s and 90s, as far as I understand it, compilers had very good support for allowing you to write assembly kind of in line with your C or C++ code. So you could have a section right here, it looks like _ASM and then brackets, and the compiler would take that assembly that you put in there and inject it into the final binary. And you could actually use it. Why would you want to do this? Well, in that era, compilers, right, compiler research was not quite as far along, okay? So while compilers were nice to have, they didn't always produce optimized code. And in this devlog post right here, ESMatP, I don't actually know who that is, explains that there was a good bit of assembly code mixed in, but it tended to be used in kind of very specific situations. For instance, they found that the compiler was not generating very high-quality rendering code. And they were able to go in and write some assembly code that was just dramatically faster. I think he says like a 10 times speed up. Yeah, 10 times sprite improvement performance for the render, right? And so it's you get this ability to dramatically speed up a part of the game. You can improve the resolution. You can do a lot of interesting stuff. Okay, so it's it is the kind of thing to keep in mind. We don't really do a whole lot of that these days, but on a rare occasion, you might still have to, particularly if there's something unique about the hardware that you're going to have to go in and deal with. Okay, so anyway, you can read more about that post if you want to. So we have a quiz coming up. If you look at the schedule on quiz 2, and it's coming on Monday, okay? And what the contents of that are going to be, it's going to be some of the things we've talked about recently, okay? It's going to be standard questions related to the C++ build process. So do you remember what the 4 main questions when you go to build something in C++ is, right? Which headers do I want? Where should I look for them? Which libraries do I want, and where should I look for those libraries, okay? And if you can answer those questions, if you can navigate the crazy UI, then you can get things to build. You can get things integrated into your project, okay? Pointer invalidation, which we talked about on Monday, is a very common issue. It's something you should be aware of, and you might have to answer a question or two about that. Game loops, which you should be getting familiar with just via your homework. Scene and actor templates. This is a topic that is a big deal on homework 4. This is kind of your first exposure to them. It's this idea that we can create this reusable blueprint, this reusable prefab or template of a type of actor we want. And then we can spawn and instantiate those into our experience, but we can also override certain properties on them, okay? So we'll talk more about that today in our lecture. You're going to want to kind of refresh yourself on standard containers, okay? So things like vector, right? Classic. Things like map. Do you know the difference between map and unordered map, okay? What's the difference between a map and a set? A set versus an unordered set, okay? Just make sure that you've kind of refreshed yourself on why you might choose one versus the other. Usually it comes down to runtime performance complexity. With the unordered version of these containers, you usually get O of 1, constant time lookup. If the ordered version is what you need instead, then you'll get something like log n typically via some sort of a tree internal structure, okay? Shared pointer is not something we've talked about yet. We're probably going to talk about it in discussion. And in the final version of this course, it's the kind of thing that we would probably talk about today, or we would have talked about it on Monday, okay? But producing lecture content takes a ton of time. STD optional is something that might show up. I think we're going to talk about it during discussion on Friday, and if we don't, I'll remove it from the quiz, so you don't have to worry about that. A quick preview. You know what pointers are. Okay, it is a reference, basically a small little int kind of that allows you to point at or refer to something without making a copy. Okay, pointers in managing memory, right? Putting memory onto the heap is kind of a big deal because if you put it onto the heap, it won't get collected, it won't get recycled like stuff on the stack will. And so, how do you remember to delete stuff on the heap when you don't need it anymore? Shared pointer will kind of manage that for you, okay? Shared pointer is a pointer that will keep track of how many pointers are referring to a particular piece of memory. And if all of those pointers go out of scope, if the pointers are collected and we're about to orphan and abandon some memory on the heap, it will get cleaned up automatically for us, okay? So shared pointer, good stuff, and you will learn more about that on Friday, okay? Composite keys is kind of an interesting topic. One of the challenges that you'll have on your homework 4, okay, especially when it comes to performance, is how do I make objects that are nice and hashable? If I have an X position and a Y position, and I want to mark those two positions as being occupied, right? They're blocked, someone's standing in them right now. How do we deal with that? Okay, One way to do it, right? One kind of ugly way to deal with this would be to go and do something like unordered map, right? An unordered map keyed on an integer, the first integer being x, leading you to another unordered map with a second key of int, leading you to a final data structure which actually holds the actors that are at that location. And not the actors themselves, but a pointer, a reference to the actor object. Because remember, you do not want to make copies, okay? So pointers help us with that. Yeah, this is nasty, okay? It's ugly, hideous. The boilerplate code for making this work is probably going to be very annoying to write and kind of easy to mess up. I would not go for something like this. And I might even say, I don't care about the performance. I just don't want this in my code base. I don't imagine the performance is going to be spectacular. In any case. Something you could do that would be kind of basic, but at least very convenient, is you can say, you know what, I'm actually going to convert my x and y coordinates into a string and just turn it into a string, okay? The string should be hashable, and you can then use it in a very simple map as the key, right? That's something you can do, and that wouldn't be a bad idea to start with, okay? Your code will probably be relatively simple and straightforward. It may not be very fast, okay? As far as I understand it, strings are not all that performant when it comes to hashing. And so this is something that might be a good idea to start with, but then you would target it for replacement or experimentation later in the project when you discover that you need more performance, okay? Something that's kind of readable is using a pair, okay? An std pair, int. You've kind of created yourself a xy kind of custom data type by doing this. And you could use that as a key. I think that's possible. And I imagine the performance probably isn't too bad, though you will have to create a bunch of pair objects. Those might get copied. That might be slow, okay? You might need to experiment with that. Yeah.
There's no decent hash for pair, actually.
There's actually no hash function for a pair. If I recall, there's a way to provide it.
You can write your own.
What's that?
You can write your own SCP.
There is hashing for it. There's no hash for the GLM IDEX. You have to
Okay.
make your own for that.
Gotcha.
There's actually a hash provided in the library for the GLM indexers.
It's like an experimental thing, I think I saw.
Yeah, I tried to use those. It doesn't compile.
Okay. Yeah, on occasion, you will need to provide your own hashing function with certain data types. And pair might be a case of that. Kind of, in my opinion, the most interesting kind of approach, and the approach that the instructor solution actually uses, and that's not saying it's the fastest, but we found it to be fairly fast, is to actually pack your x and y coordinate into a larger data structure, okay? The idea here is that if you take 32 bits for your x and 32 bits for your y, you should be able to pack them into a 64-bit data structure, right alongside each other. And this is usually called a composite key, okay? And it's kind of an interesting little trick that you can look into. Here's some sample code that you can use if you want to try it out. The idea here is we're going to send in an x and a y integer. I think these ints are 32 bits. And we're going to get out a 64-bit integer data type. We can do a static cast to make sure that the right type. We can then say that we want to create, and basically we're going to start and create that 64-bit result. We put our x into the rightmost bits. We can then shift those bits over 32, and then we can put the y into the rightmost bits. We now have a 64-bit key that has both of the 32-bit numbers in them. And that hashes, I believe, extremely fast. But it's been a while since I tested the performance. In any case, that is what the instructor solution currently uses. Yep, blah, 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 blah. Yep, packing the bits together. Cool stuff. Any questions, comments? Okay. So some general performance tips, and then we'll get into our main lecture content down here. Homework 4 performance test cases really aren't a joke. They are pretty difficult, okay? You're going to want to make sure that you look at the homework 4 assignment spec pretty closely. We provide sample code for certain things, like loading JSON in. And as far as our experiments last year, that was the fastest way we were able to find to do it. So if you go to 498, if you go to the assignment spec, most of these specs have some sort of comment on the topic of performance toward the toward the bottom. And let's see if we can find it here. Reflections, nope. Notes on performance. So there are quite a few bits of information in here. And these generally explain kind of what the instructor solution is doing, or at least hint at what it's doing, okay? You can try many of these things out. I think the code for loading stuff from JSON quickly, is right here. So you can check that out. You can use it if you want to. At the very least, that should help you catch up to us. But you can also experiment if you want. A general tip, I highly, highly recommend that you use either STD Chrono, which has some tools for timing and instrumenting bits of code. If you want to learn and get a good feel for how fast a particular function is, or a particular chunk of a function, then you can use this, okay? You can also use your IDE's profiler to get a good feel for what might be going wrong, okay? So here is some of the staff solution code for Homework 4, just a tiny little chunk of it relating to the creation of actors. And what you can do in Visual Studio, it's a bit different in Xcode and on Linux, but you can go to Debug, you can go to Performance Profiler, just like this. You can kind of check all the things you want. Okay, I want to know about CPU usage. I want to know memory usage. How about some file I/O? Don't want to read things from disk more than you need to, okay? And so here we go. We've got our program up. It's loading the first scene. Everything is going to run noticeably slower when you're profiling. So this seems like probably twice as slow. Run a few commands. I think this is test case 6.2. Okay, S, walk south a little bit. Okay, and we're going to go ahead and quit now. Okay. So the program is quit. I can kind of close it here. I can stop collection. Click that little stop button. Visual Studio is going to kind of look at all the data that it captured, all the data it recorded, and it is going to go and kind of look up what information it has, okay, on function calls, okay, on which lines are really, really hot, okay, where's all your time being spent. Something that you might want to think about, though, is from what I understand, these tools, the Performance Profiler works much better. It gives you much more detail if you're actually using the debug configuration other than release, okay? You're probably doing a lot of your own testing and development on release because this is the configuration that really matters for the autograder. However, when it comes to debugging and testing performance, you may want to get debug working, okay? You'll probably get better results from your profiler. In general, in my experience, Windows is definitely my favorite platform to profile on, to check performance on. And it's because of tools like this. I think Xcode has some tools like this, but Xcode is, it's not a place I like to hang out, you know? Okay, so once this finishes processing, you can actually go in and you can check on, which files am I reading? How much data am I reading from these files? How long is it taking? I like to go to CPU usage, at which point you can get some information about your heaviest functions. So I can see here that my top functions are, in this case, it looks like some external calls. I'm not entirely sure what those are, but we've got a function called getActorsAtLocation, and it's not the fastest in the world. Okay, it's also not the slowest, though. It is consuming about 4% of our runtime here. these aren't our top functions. That's not a top function, 4%. You can go up and see that a lot of times, 70% of our time is in this function called actor update. This is a function that is going to go through and it's going to help the actors do their job. I'm not going to show you everything. But you can see here that these highlighted lines are suggested to be just a little bit hot, okay? And if it's possible to optimize them, we might consider doing so. Here we can see that this function, SceneDB check for collision, okay? We provide an X and a Y location, is eating up about 20% of our time, okay? And so going in and optimizing this function in particular, and then rerunning this experiment to try and get that percentage number down, is going to be something that might help us, okay? So you can spend a lot of time worrying about, hey, you know, I'm going to make this little optimization here, this optimization here, this optimization here. But you really, really, really want to profile, okay? You want to profile so that you know where to aim your efforts. If you optimize a function that's already super fast, it probably isn't going to help you that much. Or if you optimize a part of your code base that only gets hit once, all right? And optimization isn't going to have a huge impact there. But if you've got functions that are being called thousands of times, as we can see over here, then figuring out how to optimize that could be a really, really good idea, okay? How can we call it fewer times? How can we make it go faster when we do call it? So I recommend using these profilers if you haven't. And again, see if you can get debug configuration working, because I think you'll get much better data if you do that, okay? A quick note on the topic of some actually very interesting concepts. We haven't talked about these very much. And frankly, it's the kind of topic I want to refresh myself on before I talk to you too much about it. But when it comes to avoiding copies in your program, tools like std-move, right? Tools like emplaceback may be of interest. Here's a chunk of code right here. Now, I think actually in the instructor solution, we actually messed this part up. So it actually is still creating a copy. But if you look at this piece of code right here, we are creating a new actor, okay? This is a function that takes a chunk of JSON and basically it returns us an actor object, okay? Now, this actor object is being stored in a variable right here, actor, new actor. But eventually, we want to get this actor onto an actors array. That's kind of our database, and that's where that actor will live forever after, right? Happily ever after. What's going to happen here is when you go to do something like push back, I believe that it actually creates a temporary copy and then puts it onto the container. If you go and down here, if you mess with this variable, new actor, you're dealing with a copy, okay? But then there's another copy on the array, all right? Well, what if you want this variable to not be copied? You want to get it onto this actors vector into this container, but you want to avoid that extra copy. This move function, std-move, is going to try and do that for you, okay? After you call std-move, this variable, new actor, is not going to be valid anymore. If you attempt to use it for anything, you're probably going to get some undefined behavior. Your program might crash, okay? And it's because your variable, right, the data really isn't in the variable after you call this function. You've kind of taken your data and injected it straight into the container, and a copy was not made. Okay, so this might speed you up a little bit. I think you need to produce a what's called a move constructor to get the full benefit, though. And I don't think our staff solution actually does that. So I don't think this is optimized this semester, but it will be soon. So yes.
Can people generate if you don't use any has deleted?
What's that?
A move constructor can auto-generate.
Okay, yeah. Maybe that's happening. I'd have to go check.
You don't have anything that stops it from auto-generating, like a unique pointer.
Gotcha. Okay, so you might consider something like this. You should also consider looking into the difference between pushback and in placeback. It can have some performance benefits in certain circumstances. But this is definitely, these three things, in addition to stack versus heap, is a lecture that's going to be coming probably not this semester, though, probably next semester. We'll see. I might talk about it in a couple weeks because performance is going to continue to be an important challenge throughout the course, okay? So anyway, look into things like std move. The basic idea is I don't need this variable anymore, and I don't want to make a copy, okay? I want to put this variable onto the container, and after you do that, you can't use it again, but it's going to be a bit faster, all right? Okay, could improve your loading performance, I imagine, especially when you're quickly creating a bunch of objects. In general, you don't need anything too exotic, okay? The stuff that we've talked about in class are things that the staff solution uses and in some cases doesn't use, all right? So I would very much focus on the idea of, is there any way I can skip work, okay? Can I prevent myself from having to do certain bits of work? I don't recall how much sorting homework 4 requires. I think it does require some sorting for things like dialogue printing and stuff like that. But how can you make sure you're sorting the smallest amount of stuff possible and you're sorting as rarely as possible, okay? To keep, achieve correctness with the least amount of effort. And one last final thing. If you cannot get these final performance test cases, don't lose too much sleep over it, okay? These are not easy, and it probably won't impact you that much on future test cases. Our engine does develop and kind of grow and grow, okay? Last week's efforts do matter this week, but in general, your engine changes quite a bit. You'll find yourself refactoring a lot of stuff, pulling certain pieces out, putting certain things in, and so you should be okay, all right? Just because the performance test cases don't work out this week doesn't mean you aren't going to nail them next week, okay? All right, cool. And I think, this was a funny comment from Twitch last semester. Ideally, I would just deactivate an actor and not delete them. I will die before I use the heap for my actors. Kind of a funny comment, okay? Again, placing stuff onto the heap. Why do you put things on the heap? What are a couple reasons? Yeah.
The stack has a limited memory space, and you use it for however deep you go in functions.
Yes.
Heap, you got a lot of memory space to work with. You're not going to run out.
Yeah, absolutely. So heap is where you can just dump and dump and dump things into memory if you need to. The stack is comparatively very limited, okay? It's very fast, but it's very limited. And especially if you cannot bound the size of your program. If you can force your game engine in all of your games to limit yourself to a certain number of actors, certain number of images, certain number of scripts, well, not scripts probably, then you might be able to get away with optimizations like that. But the heap is a great general purpose place for memory, and so you're probably going to end up using it, okay? But just keep in mind where certain things are, okay? You can get big speed ups from that. Quick debugging tips, right? Pay attention to those warnings. If they're showing up in your IDE, they could save you some debugging later. You might get warnings being generated by a third-party library you bring in. Like RapidJSON famously generates a ton of warnings, if I recall. Yeah, I'm not sure if it's still doing that. We're still using the same version, so I suspect it would. But not a whole lot you can do about these, okay? I would just roll with them, not the end of the world, but look for anything generating a warning that is coming from your code base, okay? All right, let's see here. Your program is single-threaded, but if it changes, if the results change, if you're getting inconsistent correctness on the autograder, there's a chance you could have some undefined behavior, okay? You could have variables that aren't getting initialized. You could have some other funky stuff. So make sure to look at those warnings. The IDE should try and point them out to you. And here's an example, right? Okay, so in your warnings, oops, you have a member variable of an actor. It's called velocity, and it's not initialized, okay? And so you might get really weird, inconsistent behavior if you were to submit like this. So keep an eye on that, and that'll help you out. Okay. Any questions or comments in general? Awesome. So in the future, a lot of this stuff will be formalized into an actual lecture. Thank you for your patience. It's a question. Austin, why are you working on a new course when you've got 440 and 498 to kind of finish and add content to? It's a very good question. Thank you for asking. So one big thing is that speed really does matter when it comes to getting new courses out, right? Even if a course is missing a lecture or two, it can still achieve most of its impact for students. But if I delay a couple semesters to get a new course out, then that's several hundred people who won't have that knowledge. They might never get that knowledge. And so there's a lot of pressure to get the course out and then go back and start fixing it up. Every semester, these courses get new lectures and polish. The homeworks get better. The autograder gets more stable. So it's going to take another couple semesters, I think, to get 498 perfectly stable. But I appreciate your patience in the meantime, okay? I know it's not easy. All right, so a question. What do you see here? All right, has anyone played this game? Elden Ring, fantastic, fantastic game. Did just gangbusters numbers a couple years ago, okay? And when I look at this, I see just an incredible amount of detail, okay? The scale of this game is incredible, and to my knowledge, the team did not really use much procedural generation technology to make this world come to life. It's a very big world, and it was kind of handcrafted as far as I know.
They did. It's both a meme and kind of not a meme that they copy-pasted a few elements from like parts of the map to other parts of the map.
Sure. Oh, yeah.
It's either copy-pasted or you're getting a procedural gen. So.
I say, that doesn't sound like procedural generation to me. That sounds like the designer handcraftedly copying and pasting stuff.
Either you're getting the copy-paste or it's going to be procedural gen.
Yes. So other games like Ghost of Tsushima take a very interesting approach. And I know about Ghost of Tsushima because we've got Wolverines working on it. But they use a lot of interesting procedural generation technology to get kind of the larger world blocked out. And then they go in with their design team, which is not super huge. Sucker Punch is a relatively small team. And they go into certain areas and they start adding tons of great detail in a handcrafted way. Elden Ring right here is handcrafted, as far as I can tell. Okay? And it really is an amazing thing. If you look into what you see here, we've got lots of different actors, right, in 3D space. Each of those actors have vertices, they have geometry, faces, edges. They've got materials, okay? But as we said, there is some copy and paste, right? You're going to see different enemy types, and you're going to see those types instanced in many different cases, okay? So I think I can see two of the same enemy type, right here. We've got one actor template, and we're spawning in two kind of common enemies based on that template, okay? But when you look into the scene, you also see kind of fuzzier, mushier, but important stuff as well, right? Relationships between characters, growth, systems, okay? Memories, like the first time you walk over the hill and see the gigantic Erd tree, okay? This stuff really does matter, so don't forget how magical this stuff can be. We have to somehow represent gigantic worlds like those we see in Elden Ring. And the question is, well, how do we do it, okay? When you look at the Unity editor here, okay, what do you see? Well, if you were to break down what we see here, you've got a scene, okay? We're using that theater terminology. And if you see, we've got three actors, okay? We have a cube, we have a directional light, and we have a main camera. We have three actors, and yep, you can see them right there visually, okay? So three actors. And if you ask, well, what differentiates these actors from each other, okay? These actors have a lot of properties, okay? They have actually a lot of components, which we'll talk about later. The first thing is they have different names. So we've got our actor, we've got a name for main camera, actor, directional light, actor, cube, okay? We have transform information, okay? We have position data, rotation data, scale data, okay? And every actor has these things, okay? And more, actually. So some actors have information about how to render them. Some actors have information about how they should collide and stuff like that. if you think about, okay, how are we going to write this all down? How do we get this into a file format? Well, you might say we want to use a standard format, okay? Why would you want to choose a standard format? Why don't we just roll our own? Has anyone ever tried to do that? You say, I'm going to save my data in a text file, and it's going to have a structure of first the name comes, okay, and then this comes, and then, oops, there's another object, so we have to have a delimiter with some question mark keys or something, right? Yes? Parsing, right? So support existing technologies, okay, is a very, very good reason, okay? But which standard format should we use? Any ideas?
Protobuf.
We need a protobuf. That's an interesting idea. We have a lot of features we're going to want to support. So what kind of format should we use? Well, you can ask yourself, what do modern game engines use? What does Unity use? And as it turns out, Unity uses something called YAML. Have you ever heard of it? So YAML, yet another markup language. It's kind of a recursive name here. And if you open up a Unity scene file or a prefab, you're going to see a chunk of YAML. You're going to see something like this, okay? And there's a lot of kind of information on here. One bit of trivia is that YAML, the website for YAML is actually written in YAML. So this entire website for this markup language is being represented, and it looks actually pretty good in YAML. This is a valid YAML file, which is kind of interesting. Oops, let's see here. YAML, okay. So it was released in 2001. Okay, what's up?
This is the name.
Oh, yeah. It was released in 2001. It has a very minimal syntax compared to other languages. It doesn't have a lot of white space. It does not have a ton of crazy carrots, okay? Have you ever had experience with XML? XML, brush-ins with XML, these kind of files tend to be just extremely verbose, okay? You have a person type, okay? And the content for that person type, and then you have to have something just as large to say this is the end of that object or value, which seems like maybe it's a bit overkill, yeah? Compare, it's much, much more efficient, okay? However, one thing that's a little bit spooky is that it relies on white space, all right? And so you have to be a little bit careful, I think, with your indents and stuff like that. It's kind of like a Python situation. Have any of you gotten blown up by accidentally mixing spaces and tabs in Python? Anyone? And as we all know, you go with spaces, right? And that's, yeah, that's how, Anyway, YAML has some really killer features, and you're going to laugh, but this is one of the few file formats that has a built-in form of commenting, okay? As in, you can actually put, kind of in a Python-style fashion, you can put a pound sign, okay? And then you can write comments, okay? If someone's reading your file format and trying to figure out where do I edit something, a comment can really, really, really help, all right? Actually, a killer feature, because most of these file formats we're going to talk about don't really have it. Yeah?
So is the commented thing a feature of the language itself, or is that just something like say for C++ C#?
I'm pretty sure that it's built into the language. So it doesn't require any hackiness with the IDE to work. I think if you want like JSON comments, you need some help from tools and IDEs to make that work. But it also has kind of cool reusability technology. For instance, anchors and aliases. We talk about templates and prefabs, okay, and blueprints. Take a look at this. So if you ever see the ampersand, right, and sign, this is defining kind of a chunk of configuration. And so here's the example, right, a chunk of configuration, build a test, okay? And if you ever see the star, you're kind of dereferencing that name. So we can have star build test, and what will happen is this chunk right here will get copy and pasted to here, and will also get copy and pasted to here, okay? That's kind of what's going on. So very, very powerful stuff, a method of reuse built into the file format itself, okay? In the Unity script, we have little references right here. File ID 8, for instance. This is a reference to another chunk of YAML, okay? So references, templates, stuff like that, it's all good. If you have a game object that has a prefab, a template, okay, like your actors can have a template, you can get that information here, right? So our game object is going to have a prefab of some other object that we have to go look up in the same file, okay? So YAML is a powerful choice, okay? And Unity was very wise to pick it, in my opinion. What does Unreal Engine use for its file format? Does anyone know? Oh yeah, if only. Yeah, so Unreal goes with a very performant choice, okay? So let's open it up. You are going to find map files, .map files and .blueprint files, I think, or .uasset files, okay? When you open up this scene, here's what you're going to see, okay? A UMAP file. If you open that up in a text editor, okay, you're going to find this garbled mess of references that you can read, right? File paths, basically. But then a bunch of binary stuff that you cannot, okay? Things have been packed. The objective here is not readability or ease of development. The objective is performance. And so it's not something we can very easily study, but it is going to be faster. It's going to load a little bit faster, okay? It'll be more performant to search into, but it's going to be a pain, okay? What about Godot? Any idea? Okay, so this is what Godot scene looks like, okay? We got a couple nodes in here. We've got our ground cube node, we've got a light, and we've got a camera. Pretty much the same as Unity, okay? Now, if you look into Godot, you'll find that your maps, your scene files, are called .tsn files, TSCN files. This stands for a textual scene. And if you open them up, you're going to find a file format that you probably have never seen before, okay? This is a file format that is custom, okay? It's a custom file format. It's a custom textual format. So here we are with Unreal that has a custom binary format, and it's justified for performance reasons, right? Binary format's going to load much faster, okay? We have Unity with a standard textual format, YAML, okay? And we don't get performance there, but we do get high readability, ease of development. So my question to you is, what do you get when you have a custom, non-standard textual format, okay? Which of these benefits are you getting when you go that route? Because it seems to me like you're getting kind of the worst of both of all worlds, right? I think we've got audio. Hello? Hey, can you quiet the video, please? Thank you. All right. All right. So, a very strange choice, okay? It wouldn't be the first that Godot has made. But, it is their own thing. At least they have flexibility. They can customize it to support the engine if they want to. So, if we take a closer look at it, we can see that there are kind of 4 nodes in the scene. If you saw 3 nodes previously, right, we actually have a final node, the spatial node, that I believe actually serves as the container for the entire room, okay? So that's why it's a little bit different than you might expect. Yep, and it looks like this, the hierarchy. You can see there's some parenting going on here. So the ground cube node and the player camera node are both parented to the spatial node, and the player light is parented to the player camera. So where are these parenting little bits placed? It's right here, right? Super easy to see, okay? The parent of the ground cube and the player camera, they are parented to dot. Like, what does this mean in Linux, the dot? Anyone know? And I think it means this in command prompt on Windows too. It means current, right? The current directory, the current file in this case, okay? This is the level 2 .tscn. And so we're parenting to that topmost spatial here. Here we can see that the parent of the light is the player camera, all right? So at least it is easy to read, Okay, we also get type information, we get properties, or what X, Y, and Z we're at, what rotation are we at. And they do provide a file format description, so you can read about it and learn about it, figure out how to parse it on your own if you want to write a compatible tool or something. So, which format should we choose for the engine that we're making in this course? What would make sense based on this lecture talk? Yeah. Yeah, I vote YAML as well. And if I had known about YAML, I probably would have chosen it for the course. But I didn't know about it, okay? YAML is the obvious choice. We could choose something if we wanted more performance. In fact, one of the really cool research features you could do at the end of the semester is a performant kind of custom binary format. Right? And then you can kind of check, okay, how fast are we loading scenes now? Is it worth it, right? A custom textual format, not a great idea, okay? So we ended up choosing JSON. Why did I choose JSON? Well, it's because it was the best thing I knew of, before actually doing research into it. I was focusing more on the engine part than the representation of the scenes. Yes?
Is JSON not a standard? Because I've understood you could use JSON
Oh, yeah.
to load a bunch of stuff and you set up that on the script.
Yeah.
Is it not a standard?
JSON is absolutely standard.
It's used
Yeah.
everywhere.
Yeah, JSON is pretty universal, okay? It's JavaScript object notation, okay? It looks like this. This is what your homework 4 scenes are going to look like. This is a scene that has 3 visible actors on it, and each actor has a name, and each actor has a set of standard properties. Sometimes they have the properties, sometimes they do not, okay? Extraordinarily popular. It, again, kind of popped up around 2001, and its origins are mainly in web development. The mission here was that we wanted to have a standard kind of data format that could be sent to applications just willy-nilly, right? Applications that we don't necessarily, that aren't necessarily looking for particular keys or haven't agreed upon a certain format, okay? JavaScript is going to be the format that everyone expects and everyone's going to know how to parse and use. There are a lot of really good parsers out there, right? Right, you'll do a bit of this with rapid JSON, but you can basically go into objects. Objects can be nested. You can go into arrays. You can grab different properties. It's very human readable. The biggest issue is that it does not support any sort of comments. Do you know how to support comments in JSON? What you do is you create a property that's called comment. And you just kind of roll with that, okay? That's how it goes. Super easy to parse. There are lots of great tools out there for parsing JSON, and they're very fast. It's interoperable. So you can send this piece of data out of one program, you could send it to another piece of software that it doesn't know about, and it's just going to work, okay? Some of the cons is that it's kind of a verbose language. Now, it's not nearly as verbose as XML, okay? But it is kind of verbose. It lacks features. It doesn't have comments, okay? You know what another big issue is with JSON? It's very, very picky, all right? It's very, very picky. In fact, let me show you something, okay? JSON Editor Online. Okay, do you see this JSON object over here? Do you see this bit of text over here? This is all valid JSON. But you know what I'm going to do? I'm going to ruin everything. Okay, this is now completely ruined. All right, it's no longer valid JSON. A lot of parsers out there, including rapid JSON, won't parse this, I don't think. It will give up and yell at you. So what is the problem? Well, you see, I accidentally put an extra comma at the end of my list, right? I mean, why wouldn't I? There might very soon be another thing, and then it's going to be valid again, right? But no, if you have a trailing comma, you are busted, and it's not going to work, okay? JSON is very, very picky like that. So it's a little bit of a regret. Okay. So, yep, no comments. YAML doesn't have these cons. Why didn't we choose it for the course? Because I didn't know about it. So maybe when we update to SDL3, maybe next year, I will also update the engine to YAML. That would be kind of interesting. Okay? If you look at a block here, right, for every key we add, we're going to have to write some C++ code to make these keys mean something. So when you are developing your homework 4 and when we go to homework 5, you are going to have to write some of these keys, but the keys themselves don't mean anything special. There are no built-in properties of the JSON markup language that makes vel y meaningful to your software. In general, you will write a new property into some JSON to support a feature, and then you will write some C++ to search for and grab that key, grab that feature, and then put it to use. Okay, that's kind of how you're going to iterate here. Now, one question is, eventually, our users are going to want to have keys and features that we can't support. Okay. What if our users want to write a space shmup game and they want to define, what the enemies look like? We are not going to support, by default, an enemy visuals for shmup key, okay? So at a certain point, we have to step away from this process and we have to say, user, you're going to write the keys and you're also going to parse them, okay? And the question is, how will we make that handoff work? On homework 7, which is, again, I think my favorite homework in the entire course, you'll figure this out, okay? And the expressiveness and creativity of your work is going to, it's going to go to the moon, all right? A quick aside, XML was the language used on The Sims 4, okay? So an internal story. The Sims 4 was, I think, Maxis, kind of their first big project where they really, really, really wanted the data in the game to be tweakable and moddable by users. But also they wanted designers to be able to go in and tweak things without having to grab an engineer or spend an engineer's time, okay? If you are playing The Sims and there's a magic number in the code somewhere that is like, oh, how much time does it take for a Sim to eat a sandwich? If you're a designer and you want to speed that up because you believe it will be much more fun, in the past, you kind of had to go find an engineer who had time, and then they had to spend their time to find the number and update that number somewhere in the code base to what it needed to be, okay, what you wanted it to be. On The Sims 4, there was a big effort to externalize as much data as possible, and so XML was how it was done, okay? All those properties, how long does it take to drink something, eat a sandwich, use the restroom, okay, talk, was put into XML. It stands for Extensible Markup Language. On the Sims 4 team, no human ever edited the XML directly. In this course, we will be editing and messing with the JSON directly until probably the final 2 weeks, when some of you might build an editor to do it automatically. All of the XML was actually automatically generated from our Python scripts. So our gameplay code was written in Python 3 if I recall. And if your variables had a certain type, or I think if they had a certain attribute or naming convention, I don't quite remember, a tool would look through the Python scripts, find those variables, and would basically put them into an XML format and then dump it all out to disk. Okay? Gameplay engineers would write the Python. Yep, a C# tool would crawl through the Python files, find the public variables, and generate XML on disk for them. Now, we had a custom tool, I think it was called the tuner, and it would load these XML files in. It would render and display all of the values that we could tweak, and when you made changes, it would actually write back to the XML files. This helped us avoid things like typos, okay? It helped us keep our references between objects really nice. It also enabled some code completion. When you launched the game, the XML would get loaded by the game engine, and it would go through the Python files, and all of the values in the XML would kind of be baked back in as the default values for those Python variables. okay? In that way, you could edit the XML via a tool, and the XML would affect the logic of the game when you next ran it, okay? Anyway, so it worked, okay? It was a little bit of a slow iteration loop, but it did work. So how to make assets and configuration easier? Reduce, reuse, and recycle, okay? You're very used to functions, you're used to classes as a method of code reuse, inheritance, but what about assets? When you want to reuse an asset, not a class, but maybe an enemy configuration, or you wrote a cool character for your homework 4, and you want to reuse that character, plop them around everywhere, like a Spartan, right? We create a Spartan character for our text adventure game, but we need like 50 Spartans. What do? Well, actor templates are our method of dealing with this. And if you've used Unity or Unreal, you probably already have knowledge of what these are, okay? In Unity, they're called prefabs. In Unreal, they're called blueprints, okay? In Godot, interestingly, they're called scenes, and that's quite confusing, okay? So here's the situation, okay? Most of these objects right here, these actors are actually the same. Spartan 0, Spartan 1, Spartan 2, Spartan 3, okay? They are all blocking, for instance, okay? They all have the same dialogue, okay, for instance, and they all have the same view. So the only things that are different between these, the name and the X and the Y, okay? And even the name could possibly be the same without too much of an impact, okay? The idea here is that we want to take the things that we can reuse and put them into a template. So here, this Spartan.template file, it has the name Spartan. This is the view that all Spartans have. All Spartans will be blocking by default, and the default dialogue for a Spartan will be 2 + 2 = 5, okay? And so what we've done here is kind of an act of compression, okay? And so now we've gone from this right here. Notice, in this many lines of code, about 30, we can fit like 3.5 Spartans. It's not very good. Now, in the same amount of code, we can get 1, 2, 3, 4, 5.5. Okay? So this is more efficient. Okay? It's faster. You don't have to write this much. Remember, when you're developing games in this engine, you're editing and writing this JSON yourself. Okay? So this is not a fast process, but this speeds things up enormously. Okay? And so the idea here is that we're going to compress things. We're going to use less data. We're going to have faster loading. We're going to have fewer typos because we're doing less typing. There are less things we need to configure and change for each character. Okay, changing a Spartan is easy. And we have a prefab, right? We got a blueprint now, okay? We call this a template, all right? So I couldn't find anything from theater, so template is the terminology we'll be using in this course. One interesting thing, I don't recall if I put it in here, but just because something isn't specified, right, this Spartan, maybe we want it to have different dialogue. You can do that, right? You can say that this Spartan right here is based on the Spartan template, but we're going to override its default X and Y value, and we're going to give it a new value for its nearby dialogue, okay? That is called an override. And it's kind of actually a bit of a tricky thing to implement in your homework 4, and then especially when you get to homework 7, okay? When you're doing all of this for Lewis scripts and components and all that. So how to implement this stuff? There's some nuance here, okay? You've got a scene file, right? And you've got a template file, right? These things actually look very, very similar to each other. In fact, they are basically the same, okay? And so an idea for you as you begin working on homework 4 is you can create an actor object for every single template file that you find. You scan for template files, you find a couple, okay, you create actor objects, you configure them the same way you normally would. But then, when you are reading through a scene file and you encounter a template, okay, like for instance, right here. You're reading through your scene file, you encounter an actor that has a template. What can you do? Any idea? we say, in my scene, I'm supposed to have an actor that's based on this template, but I already have an actor object representing that template. So we can do a copy, right? Is that what you're going to say? What were you going to say?
I was just going to
Okay. So one thing you could try is just, hey, I already have an actor that's representing that template. Why don't we just copy that actor? Okay. And that's going to get us to a topic called a shallow copy. I think this might be on the quiz too. Shallow copy. Okay. So the goal here is we're implementing an actor templates feature. And the idea is we're going to create an actor representing each template that exists, and then we're going to copy those template actor objects to create a new actor object based on the template. Okay, it can then be customized. So let's say that I've got my new actor over here. Okay, and I've got an actor template. So let's see. All right. I think we have, does this have a template hooked up? I don't think it does. Yeah, okay. So we've got an actor template here, okay? By default, it has an actor ID 5. It's got a position of 0, 0. It has an image for an idle image, like a walking, standing there image, okay? It has an attacking image, and then it has a pointer, okay, in it that points to whichever of these images we're currently using, okay? A current image pointer, all right? So we've got the actor template. This new actor is not set up yet. You can see all of its data is kind of null or super default values, okay? It doesn't have any sprites. It hasn't decided which of its two sprites are the active one. It's at 0, 0, no ID yet, okay? So the actor template already exists. How do you perform the copy to create a new actor, okay? Well, you can do something like this, right? You've got a new actor here, and you can set it equal to the actor template. This will perform a shallow copy. This actor template and all of its values are going to get pushed into that new actor object, okay? Shallow copy, like this. Now, do you see anything that might be a problem here? We've created the shallow copy, and what we mean by that is we're just going to go variable or member by member, variable by variable, and just copy the same values over, okay? What's the problem?
The pointer is pointing to other image.
Yeah, and that makes sense, right? You're copying the value of a pointer, okay? You're not doing anything more clever than that. And unfortunately, though, this pointer is pointing to an image that is inside of a different object, okay? If you have an object you're copying, and that object you're copying has pointers inside of it, you will tend to run into some issues. Okay, this is the shallow copy kind of dilemma you run into, and it's a bug that you very well might run into on homework 4 or especially homework 5. Okay, when your actors begin to get a lot more data inside of it, then you might want to put some pointers into your actors. Okay. So this is very, very spooky, not good stuff, okay? These pointers are going to get you blown up, right? Bad news. And so, well, another interesting thing here that's messed up. Yeah, you didn't notice this, did you? I actually didn't notice it. That's how easy it is to mess these up and get a bug. But we now have duplicate actor IDs, which is probably not what you want, right? So that could mess things up. Let's see. Here's something that can fix up the situation. It's not my favorite solution, but what you can do is you can say, hey, I want to create a new actor based on a template that already exists. So I do a shallow copy, and then I know that certain things like my pointers and my IDs will get messed up. So let's fix up my pointer, my current image pointer, okay? And let's fix up my next actor ID, okay? And we've done that right here, right? So now my current image is a null pointer. That basically means I'm not using an image. That's fine. That's valid. And I have a new actor ID that basically formalizes that, hey, this really is a new actor, okay? Yes?
Are you able to do this just like by changing the assignment function?
Assignment function?
Essentially just changing like what equals means for actor.
I think you can override it. If I recall, there's something that is annoying about that, though. I'll have to think about it. But this is the way that the staff solution kind of deals with it, okay? By the way, if you want to learn or know how to do something like the next actor ID variable, basically it would use something like this. Static inline int next actor ID equals 0, okay? A quick reminder, you all know what static means, right? I'm haunted by the question because when I was interviewing at Electronic Arts, they were telling me no one at this university knows what static means. Yeah. So hopefully it's becoming different. Static tends to mean across languages that you are associating a piece of data with the class itself rather than a member of a particular instance of the class. And so anyway, a takeaway here. Please think about what is happening during your copy operations. Like always, think about where your objects are in memory, but also think about what is happening when you make a copy. What exactly are you copying over? And could that cause problems for you, like with the pointers, okay? A shallow copy is very, very convenient, okay? I think I remember the assignment operator, okay? The big annoying thing about the assignment operator, I believe that's called a deep copy. The annoying thing about a deep copy is that every time you add additional data to your members, you have to remember to go in and add that copy operation over. Otherwise, you'll be missing stuff, right? So big pain, and that's why I don't use it that much. Yeah.
Yeah, assignment operators are going to be shallow copies by default unless you specifically write a deep copy one.
Yeah.
If one of your members already have a copy operator, you don't actually have to define anything. You just make a default.
Okay. All right. So also, copy operations tend to be slow, especially as your data structures get larger and larger. So you can use pointers for indirection to get away from some of that. Okay. So what about deep copy? You can take control of that copy operation that's happening via a custom copy constructor. Here's an example. So you've got a copy constructor here. You've written a constructor. Note that this constructor takes a reference of the same type that it is, okay? So you are feeding one type of object into another type of object, okay? And you can go in and manage how values transfer over however you like, okay? Again, the upside here is that you can fix up things like IDs and pointers here if you want to, instead of doing it externally. But I really don't like this part. You need to go in and add additional logic for every field that you want to properly copy over, okay? And that's really annoying. It's very easy to forget, right? You get to adding and designing new features into a class, and suddenly it is messed up, okay? Or you forget, and suddenly things aren't copying over, okay? Some performance considerations. Copying of data can be slow. It kind of depends how much data. Small actors, right? Not all that expensive. You've got integers, 4 bytes, something like a vec2, 8 bytes maybe. Strings, I think, are around 24, and a string pointer. I think pointers. I think I've been saying that pointers are ints, but actually, I think they're closer to doubles, right? I think it depends, doesn't it?
Pointers are 8 bytes on all platforms.
Yeah.
And a string is 32.
Yeah, I think over time this has shifted. But you've got something like 68 bytes total for this kind of tiny, small actor. But as you start to add stuff, right, health, rotation, all sorts of variables you might want on an actor, like your actors are going to start getting bigger and bigger. The homework 7 actor, at least when I calculated this, was 600 plus bytes, okay? And so, right, your goal then is to make as few copies as possible. If you need to reference an object but don't want to make a copy, you can point to the object via a pointer, and that will save you some memory. Also, prevent you from violating dry. Beware of your functions, okay? Pass by value is a pretty big deal. This is something you want to check in your homework 4 functions. You want to get this right for sure. But with this, what we have right here is pass by value. So every time you call report actor ID, your actor object is going to get copied And so this can lead to performance issues, particularly if your object is really big, but it can also lead to correctness issues too. If you send in an object, right, to a function like this, and that function is meant to adjust or fix up or process the object, well, it's actually processing a copy, right? So you won't get to keep any of those changes, all right, when the function concludes. So you got to be careful about that. So use pass by reference. You learned about this in like EECS 280, I think, or maybe 183. Put that ampersand in there, and then that is the object going in, okay? All right, cool. You can also pass by pointer if you want to. So in this case, you're passing the pointer in, which means once you use that pointer to dereference it and get the actual object, you're dealing with the original object as well, okay? A question. How many copies of my actor exists in this function? Yeah.
Well, what do you mean by my actor? Like a specific piece of memory?
Yeah. How many times are you making a copy of actor, my actor? Go ahead.
There's two copies.
Yep. Yeah, that's right. So you've got one copy right here that's ending up on the stack, and then you're making another on the heap. My actor is still a valid thing going down this loop. If you want to do things with it after this line, you can. Okay, another question. How many copies of my actor exist here? Yep. We've gone down to 1, okay? This is a pointer to an actor, okay, that is helping us keep track of this actor that we've put onto the heap. And that pointer right there, that reference to it, is what's going on to the vector. And so we only have 1 copy. 2 pointers exist, but pointers are kind of small and they don't get larger, so we're not too nervous about those. The differences might not start to matter until you've got like millions of actors running around, or until a user tries to run your engine on something that's a really, really weak machine, like a mobile game, right? Something like that, okay? All right, so I think, we do have some information. I think I wanted to redo some of these slides, but I think we have some information on shared pointer. You'll get more of this during discussion. But something that you can consider is using shared pointer. Okay, so you can use shared pointers as a means to make sure that you're not going to forget to delete this actor, like we kind of sort of did. Okay, this main function has a memory leak, doesn't it? And so, right, what's going to happen here is that we've put this actor onto the heap, and we're keeping track of it. But when this program ends, we don't do anything to actually delete and free that memory. I think sometimes you could say that the memory, like the program ending, is the ultimate garbage collection, right? So in a way, it does get garbage collected. But what's going to happen here is that you've got these shared pointer objects. You're creating a new shared pointer to refer to an actor that's going on the heap. And if you lose track of this shared pointer, if it goes out of scope, the runtime is going to say, hey, you can't get access to this object on the heap anymore, so we're going to automatically free it for you, okay? So it kind of makes things a bit more simplified. Yeah?
So with using like new stuff / pointers, at what point do we need to make a custom destructor?
A custom destructor, if you want to run some particular logic when an object goes out of scope, something like that.
Like, will it automatically collect everything when it goes out of scope, or when we delete it? I guess like the pointer.
Yeah, shared pointer. Okay, so you can have multiple references that point to the same piece of memory. When every one of them goes out of scope, then you delete the memory automatically.
The object will get destructed, and if you have a custom destructor, it should run at that point, I believe. Yeah. So if you have an object that opens up like a file on disk and does stuff with it during its life cycle, then in a destructor, right? You might write a destructor to close that handle. That's one use case. Okay. One really cool thing about this is that if you do start using things like shared pointer, your experience with C++ will begin to resemble managed memory languages. For instance, C#, right? In C#, most of the variables you have are kind of sort of references, right? They feel like pointers. Primitive data types like numbers get passed by copy into functions, but objects, instances of a class, get passed by reference automatically. You can do things like null checks, right? In languages like C# and Java. And so the more you use these smart pointers, the more things will feel like C#, because you won't have to worry so much about deleting and manually managing your memory there either, okay? So std optional. You know how some data types, like an integer, you can't have like a null integer. It's kind of hard to say an integer has not been set yet, right? Or you don't have it yet. It's a default. If you ever have a data type that you want to create that default uninitialized value for instance, string, it's really easy, okay? You can just take the empty string to mean that you haven't set it yet. It's not finished, it's not set up yet. With actor star, with any pointer, it's easy. The null pointer is a good value to indicate that it's not been set up yet, not initialized, okay? Integer is kind of easy because you can sometimes use -1. But when would this become a problem? Any ideas? Yeah.
When negatives are on the table.
Yeah, if negative values are really important to your variable, right? Maybe this integer is meant to represent a location, right? Suddenly, -1 is a valid value, right? So is 0, so is 1. What do you use in that case? Yeah.
Infinity.
Maybe, yeah, you might be able to use that. Sometimes I use a crazy large value like -9999 or something, and then just hope that never comes up in gameplay. Yes?
I think there's a way you could literally decide to int max.
Int max.
Just set it to.
Yeah, you can use the std limits library.
Yeah. You can also use optional. STD optional is something you can check out. It's kind of fun. You can wrap any data type in std optional, and it will provide values like has value and value, so you can get the actual underlying value. This is a way to take something and basically be able to say, hey, this isn't initialized yet. It helps you make a distinction between a value that has specifically been set or one that's waiting to be set. Okay, you can use it, for instance, like this. You can say, hey, std optional, wrap an integer, give it the value 5. You can then check, hey, has it been given the value yet? If so, it contains a value, otherwise it does not. So might be useful. Setting things up, loading objects in, creating objects based off of templates. In my experience, this is one of the kind of more nuanced and tricky parts of the engine. At least before we get to things like components and Lua integration and stuff like that. Keep these things in mind if you can. Experiment with shared pointer. You don't have to use it. If you are going to remember to delete and deallocate your memory, you're fine. But think about this stuff, and hopefully it will come in use, okay? Be careful about shallow copies versus deep copies. Be careful about making your objects too large. And I think that's just about it, okay? I wish you all good luck on homework 4. I guess this was not as short of a lecture as I thought it was going to be. So my apologies there. And we will see you all next time, okay? See you next time. Good luck, everyone. Remember, this is a hard course. If you can't get 100% on this assignment, this course is designed for the average to be like a B plus, okay? So if you're getting more than a B, you're doing good, okay? And remember all the extra credit that will help you plug some of the holes at the end, okay? This is to say, don't drive yourself crazy chasing performance unless you've got some extra time It might be super fun. Don't let it stress you out. Don't let it keep you up all night. Okay? Take care of yourself, and we will see you on Monday. All right. Take care, everyone. Everyone on Twitch. I will see you later. Okay? Thank you for tuning in. Bye-bye.